Classes in Statistical Mechanics. Lectures by Professor George Phillies, based on his book, Elementary Lectures in Statistical Mechanics, Springer Verlag, 2000. And today, this lecture is Now let me go through the average again. I'm not going to try writing upside down. But here is an average, and each of these parts has a label, a name. J is the label or index. It's the thing that identifies all of the objects you're going to identify or average over. So J is a label or index. The summation is a sum over all of the possible outcomes. Yes? Right? Wj is the statistical weight. A is the thing being normalized, being averaged over. And this, at the bottom, is the normalizing factor. All of the terms are in the book.
Would you consider A the observable? Is an easier way of stating that?
A is the outcome. A is the value of the variable being observed if you have reached state J. And I am not yet, when I said state, I did not mean quantum state. I just meant state in general, like 15. So A, now, you could do this for dice, and you could say, for example, A sub j is j itself. What is the average die roll? Or you could say A sub j is j squared, or j cubed. Okay? Mm-hmm. And in fact, now I have to go through my book for a second. You go to Lecture 2. And there are some homework problems that actually deal with this. And the useful homework problems are, well, there's problem 4. Problem 4 requires that you roll the dice by hand. I don't think you want to do that. Or you could have a computer generate random numbers synthetically, except now you'd better worry about how random those numbers are. If you did this experiment on a TRS-80 or a Commodore 64 or something similar, you would discover that the random numbers repeat every 64,000 and a bit times. That is, they're not very random. However, 2-8 asks you to do some calculations on averages. 2-9 introduces the notion of moments and central moments. 2-10 invites you to do some calculations on central moments. And 2-5, do the calculation for D6s and calculate the average value of a die roll, the square, and a few other functions. So you'll do 2-5, 8, 9, and 10, and do them only for D6s. Okay. And in 2-8, I will add a piece. Suppose you have a product of two functions. One is only a function of x, a label x, and one is only a function of a label y. And x and y are completely independent. In that case, the average of the product, fg, is the average of f times the average of g. Mm-hmm. Yes? You all follow that? Mm-hmm. I have it written down here, and we'll show it to you afterwards. Prove it. And by the way, most of these are quite straightforward. The only thing that is not quite straightforward is when you get to 2-9, you are going to compute something called the central moment. And the central moment, K1, has a definition that is not the same as all of the other central moments and is buried in the book in Chapter 2, which you get to read. Okay. So we have ideal averages, and we have operational averages, and you're going to read Chapter 2, and by next Wednesday you'll have done the 4 problems I mentioned, because that's what I'm going to base the grade on, doing the homework problems.
Okay.
I don't see any reason to, on an ISP, to have exams. I'll just assign the more interesting homework problems.
That's fine. Fine with homework. I don't test well.
In any event, and you will actually do each of these. Now, you might ask, why did we introduce operational and ideal averages? The answer is, that thing I talked about, the gas problem way back at the start of lecture, that was an operational average. And you may have noticed it was real hard to do as opposed to the ones you're going to get to do, which are somewhat simpler.
Mm-hmm.
And how do we get around this? And the answer goes back to an idea of Aristotle. And the idea of Aristotle is that we can divide things into an ideal part and a contingent part. And the theoretical answer is we will replace all of these ugly operational averages, and I mean truly ugly as opposed to the simple gas problem, with ideal averages. And once you have an ideal average, life gets less painful. And that will be the next lecture.
Okay.
We are now done. You may now eat the molecular models.